Okay, hello. This lesson is on solving rational equations. So a rational equation is an equation that has a variable in a denominator. Okay, so before we solve rational equations, I think it might be a good idea to solve a regular linear equation that has fractions in it. And the one that I'm going to do is it's going to have a couple of things in it that I will use this example to explain. So here is the example. All right, and the first thing I want you to understand is that this x divided by 3 is a very common misunderstood expression. There is an understood 1 in front of it. So you can think of x over 3 as 1/3 x. The other thing is if any of them have a fraction, a lot of times it's a good idea to make a whole number or an integer a fraction as well. And so the way that you would make any number a fraction or any expression a fraction is you just put that number over 1, which means when you see just a number like 4, that 4 is in the numerator, not in the denominator. 1 is in the denominator. Okay, so those are two common things I wanted to talk to you about. All right, now we've done these before in the video with linear equations. I mentioned that if you have an equal sign, you have power. You can do whatever you want as long as you do it to both sides. So if we want to get rid of fractions, what we can do is multiply both sides by the LCD. And so the least common denominator is the smallest multiple that both 3 and 6 would go into. So the way you can do this, you can just start with a smaller number and say, okay, 3 times 1 is 3. Does 6 go into 3? No. 3 times 2 is 6. Does 6 go into 6? Yes. So the LCD is 6. It's not 3. See, you want this number to be able to use it to cancel out the denominator. That's your goal, is to cancel the denominator. So if you don't know your goal, this makes it more difficult. So my LCD is 6. Let me show you how this canceling works. So we have to remember to multiply the entire side by 6, and then whatever you do to one side, you do to the other. Well, we have something called the distributive property of multiplication over addition. So really that 6 over 1 is going to get multiplied to both of them. So a lot of times when I do this is I'm going to skip that step, and I'm going to remember that I'm multiplying the entire side by 6, but I'm going to distribute it. So I'm going to put the 6 in front of, multiply the 6 to every term, because I'm multiplying this whole side by 6 and then distributing it. All right, now the whole purpose of multiplying by 6 is to cancel out the fraction, so we have to do something called cross-canceling. 3 goes into 3 once, and 3 goes into 6 twice, and then 2 times 1x is 2x over 1, which you don't need to write. But over here, 4 times 6 is 24. And then equals, and over here, remember the whole goal of finding the 6 is to cross-cancel. So 6 goes into 6 once, and 6 goes into 6 once, and 1 times 1 is 1. So we've cleared that equation's fractions. So now it's just 2x plus 24 equals 1. That's a linear equation, so we'll move the 24 over. That's 2x equals negative 23. And then divide by 2, and x is negative 23 over 2. Okay, so that's multiplying by the LCD to remove the fractions. Okay, now when we have rational equations, that's when you have an x in the denominator. Okay, so step 1 to solving rational equations is you need to find the restrictions. Now, the restrictions are things that can't go into this fraction here. And you have a variable in the denominator, so hopefully you know that you can't have the denominator equal to 0, right? So, and if even your calculator will tell you that. If you try to do 3 divided by 0, it'll tell you divide by 0 error. Okay, so you cannot have 0 in the denominator. Now, this denominator here is x plus 1. So if you set this denominator here not equal to 0, you get that x cannot be negative 1. All right? And then over here, 3x plus 3 is really, if you notice there's a GCF, 3x plus 3 is really 3 times x plus 1. Cannot equal 0. So again, x cannot equal negative 1. So you're going to solve for x, but you're going to remember that x cannot be negative 1. And if it comes out to be that, then you would, it would change your solution. All right, so that's your restrictions. And I should have said, really, the first thing you want to do is factor, which we did here. So it's not like we didn't do it, but I'm going to rewrite that. And then the other tip I have for you, see this minus 1/2? That minus is so far away from the 1/2 that people lose it. So again, remember, I've said this many times, subtraction is the same as adding the opposite. So I typically do that, is I'll change that to, instead of minus 1/2, I'll change it to plus a negative 1/2. And then you really want to factor any expressions that can be factored, because if you don't, you won't get the right least common denominator. And also, if we'd have done this right at the beginning, we wouldn't have needed to do this. You can just tell that x can't be negative 1 here and x can't be negative 1 here. So you really should factor first. So we'll put that as step 0, factor denominators. It's really important. Okay. Now what we have to do is find the least common denominator. Okay, so because you have an equal sign, our goal, remember, is to cancel out what's in the denominator. So when you have expressions, you know, the way I think about it kind of changes. The numbers, it's going to be the same. So here we have a 2 and a 3. So the least common multiple, start with 2. 2 times 1 is 2. 3 doesn't go into 2. 2 times 2 is 4. 3 doesn't go into 4. 2 times 3 is 6. 3 goes into 6. So the LCD, numbers-wise, you do it the same way. But the LCD with expressions, you do it this way. You just pick up any denominator. So that x plus 1 is a factor that needs to be picked up and put in our least common denominator. And so now you don't have to repeat, because x plus 1 is covered, 2 is covered because 2 goes into 6, 3 is covered because 3 goes into 6, and x plus 1 is covered. All right, so that is your LCD. So what we're going to do is we're going to multiply every term by 6 times x plus 1. What we're really doing is we're multiplying both sides by 6 times x plus 1, and we're distributing. And then over here, we're going to multiply by 6 times x plus 1. And then remember, your goal is to cancel. Your goal, the reason you are multiplying through by the LCD is so that you can remove the fractions in the denominator. So if we do some cross-canceling, we get the x plus 1 divides out with this x plus 1, and you have 6 times 3, and you get 18. And then here, negative 1/2 times 6 times x plus 1, this 2 goes into 2 once, and this 2 goes into 6 3 times. So you get, this is all multiplication, negative 1 times 3, which is negative 3 times x plus 1 over 1. No more fraction. And then over here, this is over 1. So this x plus 1 cancels with that x plus 1, and 3 goes into 3 once, and 3 goes into 6 twice. So 1 times 2 is 2, and no more fraction. And so now we have a linear equation. Okay, so how do you solve this? Remember, we cannot add 18 plus a negative 3 because we have to remember PEMDAS. Before we can add two numbers, we have to do the multiplication. So that's 18 plus a negative 3x minus 3 equals 2. We have like terms on the same side, so that's negative 3x plus 15 equals 2. We don't need to get rid of them, we just need to combine them. Now we're ready to move this 15 over by adding its opposite. So that's negative 3x equals negative 13. And then we're going to divide by negative 3. And you get x equals 13 over 3. And as long as this is not negative 1, that's the solution. And you could check it by plugging it in, but I'm not going to do that. All right, let's try again. Okay, number 2. I had to change the problem here so it would work, but we have negative 2 over x plus 3 equals 13 over x plus 3 minus 3 over 2. What we have here is a rational equation. So step 0 is we want to try to factor these, and that's a linear factor, and that's a linear factor, and that's just a constant. So we can't factor anything. So now we're good to think about the restrictions. And remember, you can't have 0 in the denominator, so we will set x plus 3 not equal to 0 and find out that x cannot equal negative 3. So you can do this at the beginning or at the end of these problems, but if I remember, I'll do them first. Okay, now we are going to, we don't like these fractions at the bottom, but when we have an equal sign, we can get rid of the fractions by multiplying through by the LCD. So the LCD is a collection of expressions that when you multiply will cancel out your denominator. So you just want to pick up what's in the denominator. So there's an x plus 3 in the denominator. And you don't have to write it twice, you just need 1. And then there's a 2. So my LCD is 2 parentheses x plus 3. So I'm going to multiply these sides by 2 times x plus 3 because I have an equal sign. This is completely legal. It's the golden rule of algebra. So I'm going to rewrite this down here so we can see the canceling. So we have 2 times x plus 3 over 1 times negative 2 over x plus 3 equals 13 over x plus 3. Distribute, that's times 2 times x plus 3. And again, I don't like that minus. It's too far away, so I'm going to do plus and negative. So that's plus a negative 3 halves times the LCD, 2 times x plus 3. And remember, your goal is, you're doing this because you want to divide out the fractions. You want to clear the denominators of fractions. So it's not coincidence that x plus 3 divided by x plus 3 divides out to 1. You're left with negative 4. And then here, this x plus 3 in the denominator will divide out with that x plus 3 in the numerator, and you're left with 13 times 2, which is 26, plus, and then here, the 2's divide out, and you're left with negative 3 times x plus 3. And you get a linear equation because that's going to end up being x to the 1. So I'm going to distribute that negative 3x minus 9. I'm going to add like terms. So 26 minus 9 is 17. And so there's my linear equation. So I'm going to subtract 17 from both sides and get negative 21 equals negative 3x. I'm going to divide by negative 3. And x is equal to 7. And as long as that isn't a negative 3, then that's your answer. So you just check for the restrictions either at the beginning or at the end. You can take your answer and plug it in and see if it's going to give you 0 in the bottom of the fraction. Okay, so the next one, example 3, you can see why I had to add this step 0 factor the denominators. This is a really common error. You've got to see this quadratic and immediately think, oh, this might factor, and here's a huge hint. It's probably going to factor into one or both of these just because that's typically how we make up the problem, but we want to factor first. So we're going to rewrite 5 over, and if that factors, it'll factor into 2 binomials, and the factors of 15, 1 and 15, or 3 and 5, that's subtract to be 2. X minus 5x plus 3 equals 6 over x plus 3 plus 12 over x plus 5. So now we see that there is the same denominators, right? So if you don't, you think you have 3 different denominators, but really you only have 2 different denominators. And the other thing, it's easier to see the restrictions. So we know that x minus 5 can't be 0, which means x can't be 5. And we know that x plus 3 can't be 0, which means that x can't be negative 3. So as long as your final answers are not 5 or negative 3, you're going to have a solution. Okay, next thing is we need to figure out what we're going to multiply by. The LCD is, and you just, with these expressions, you just pick up what's in the denominator. So there's an x minus 5 in the denominator, and there's an x plus 3 in the denominator, and that's it. So you're going to multiply through by x minus 5x plus 3. So now, hopefully you're getting the idea about the numerator and denominator canceling out. I'm just going to rewrite it. I do rewrite it like this even. I don't do it in my head. I do need to write this down for me. Okay, so every term gets multiplied because I'm multiplying this side by the LCD and then distributing. All right, and the whole purpose is to cancel. So this x minus 5 divides out with that one. X plus 3 divided by x plus 3, and you're left with just 5 equals this x plus 3 divides out with that x plus 3, and you're left with 6 times x minus 5 plus this x minus 5 divides out with that x minus 5, you're left with 12 times x plus 3. So 5 equals 6x minus 30 plus 12x plus 36. 5 equals, like terms, 6x and 12x is 18x. Negative 30 plus 36 is 6. So there's our simplified linear equation. So I'm going to subtract 6 from both sides. Negative 1 equals 18x. Going to get x by itself by undoing 18 times. So I'm going to divide both sides by 18. So x equals negative 1 over 18. As long as it's not 5 or negative 3, that is the solution. Okay, if you flip over in the back, you see you have 4 to practice. I would pause the video and practice and then come back and check your answers, and I'll go over a few with you. Hello again, welcome back. I sent you off to do some practice, and then I did the practice, and I realized there's some interesting things that happened, so stick with me. We'll do one more example together. I'll also take you through this because it starts out the same. Hopefully you remember that you want to find the restrictions, and you find the restrictions by setting those denominators not equal to 0. And I got that t can't be 0 or negative 3. And then I also changed that minus 4 over t to plus a negative 4 over t. And I also wrote 4 over 1. Those are just things I do to set myself up. And then the LCD is this t plus 3 expression and this t expression. So t times t plus 3 is what you should have multiplied by. So hopefully you were good then. And then if you multiply those 3 terms by t times t plus 3, you should have gotten the t plus 3 to divide out to get 2t, and the t to divide out to get negative 4 times t plus 3. And then there's nothing that divides out here, so you get 4t times t plus 3. Okay, now at this point, you still might be able to do the next step. You certainly can't add 2t and negative 4 for several reasons. We're going to need to distribute next. And so when you distributed, you should have gotten 2t and then minus 4t minus 12 equals, and this is where it gets some, we didn't do this on the other page. You get 4t squared plus 12t. And you should have noticed that that's quadratic. And so every other one on the other page ended up being linear equation that you solved the linear equation way. Well, this is a quadratic, so you remember what you have to do? You have to set it equal to 0. Okay, so that would give you negative, I added like terms, 2t minus 4t is negative 2t minus 12 equals 4t squared plus 12t, and I noticed it's quadratic, right? So I went up here and I moved these two over, so that's plus 0 equals 4t squared plus 12t, and then this minus 2t came over and made it a plus 2t, and this minus 12 came over and made it plus 12. I always want this t squared term to be positive, so I moved these over to keep that positive. And then I added like terms, and I got that. So there we are. So got to go back and review the quadratic, solving quadratic equations by factoring. But if you remember, you set it equal to 0 and then you try to factor. But if you look, see, factoring is hard, and especially if that number is not prime. But if you look, you got a 4, a 14, and a 12, so you can actually factor out a 2. So you get 0 equals 2 times t squared, 2t squared plus 7t plus 6. That makes that a little bit easier to factor. But here's a new thing. See this 2, you've got an equation. You can divide by 2. You can divide both sides by 2. You can never divide by a variable. But since I know 2 is not 0, I can divide both sides by 2. And that means that now I've got a quadratic equation that is a lot simpler than what it started out as. So now I'm going to try to factor. The factors of 6 are 1 and 6 and 2 and 3. If it factors, it's going to factor into 2 binomials, and I got 2t and t, and then 2 and 3 and 2 work. Okay, so then you set each of those equal to 0. So 2t plus 3 equals 0, t plus 2 equals 0, and you get t equals negative 3 over 2 and t equals negative 2. Go back to the beginning. As long as it's not 0 or negative 3, we're good. So add that to the lesson, because that's a quadratic, because number 2 is going to end up being a quadratic. Number 3 is going to be a quadratic, and number 4 is going to be a quadratic. So pause and try them, and then come back and check. Okay, so here is the answer to 2, 5/3 and 1. 3 is negative 3 and 1, but then there's a whole other page, so you might want to try that. Pause the video if you haven't done that yet, and try that, and come back and check your answers. So number 5, it's another quadratic, and finally we have a restriction. See, the quadratic is 8z squared plus 7z minus 1, and it factors, and you get answers of 1/8, 1/8 and negative 1. But remember, if you put negative 1 in here, you get 0 in the bottom fraction. So that's not really an answer. It's the restriction. So 1/8 is the only solution. All right, number 6, h is negative 1, and that's the only answer. Number 7 is tricky because you have that minus, and it's in front of the fraction. So if you change that, which I did, to adding the opposite, you have to distribute that minus. So you change it to a plus, that minus, that makes that m a negative m, and that 1 a negative 1. And then it's the same. But it keeps me from missing a negative. And then there is another way to do this one. You could have moved this one over. I didn't mention it, but if you move that whole thing over, it becomes a positive. And when you have one fraction equal to another fraction, you can do something called cross multiplication. So you could have done that, which is m plus 1 times m plus 2 equals 3 times m plus 1. And that's another way to get rid of fractions. But that only works when you have just one fraction equal to another fraction. All right, and then the answer to 7 was negative 1 and 1. Ends up being a difference of 2 squares that you have to factor. And then number 8, I changed that minus to plus and negative. I got the restrictions. It ended up being quadratic as well. And so you get -3 and 1, and they're both okay. All right, so hopefully you practice all of those and have gotten really good at solving rational equations.